This video discusses a problem on Poisson random variables, and it is a part of video assignment for lecture 12 in probability and random processes course. So first, let us see what is Poisson random variable. So any random variable that takes one of the values 0, 1, 2 and so on is said to be Poisson random variable with parameter lambda for some lambda greater than 0 if a probability of that random variable for taking value I is given by this formula: e to the power minus lambda, lambda to the power I divided by I factorial. And this equation 7.1, is a probability mass function because we can show that for I equal to 0 to I equal to infinity, if we sum all the probabilities pi, then we will get 1. So we can say this equation 7.1 is a probability mass function. If we have to discuss a number of events happening in a particular time interval, and we take three assumptions, these three assumptions shown in this slide, then we can say that the number of events happening in a particular time interval is a Poisson random variable. First assumption says that a probability of event happening in an interval is lambda s plus a value that is very small compared to lambda s. Second assumption is that the probability that two or more events occur in the interval of length h is O of h, that is very small as compared to h. And third assumption is that it states, we can usually say that it is about interdependence of events. So one event happening in an interval does not affect another event happening in non-overlapping interval. Assuming the previous 3 points, we can say that the number of events happening in a particular interval is a Poisson random variable with mean lambda t. Here lambda is known as rate and lambda is the mean, and we can use this equation to calculate the probability. In this problem of finding the probability of earthquake, lambda is given to be 2 and 1 week is given as a unit of time. It is also given that the previous 3 assumptions are true. So we have to find the probability that at least 3 earthquakes occur during the next 2 weeks and probability distribution of time starting from now until the next earthquake. Because we have to find the probability that at least 3 earthquakes happen, then we can also say that we have to find the probability that 0 earthquake, 1 earthquake and 2 earthquake, all these do not happen. So we can alternatively subtract probability of 0 earthquake, 1 earthquake and 2 earthquake from 1 and get the probability of at least 3 or more earthquakes happening. And now because the assumptions 1, 2 and 3 are true, so we can say that this is a Poisson random variable with mean lambda t, and lambda is given to be 2. So we can calculate probability of 0 earthquakes happening, 1 earthquake happening and 2 earthquake happening, and then subtract it from 1. For 0 earthquake happening, k is 0, for 1 k is 1, for 2 k is 2, and we get the probability of at least 3 or more earthquakes happening. In this part we will calculate probability distribution function. So let us assume a random variable x that signifies the amount of time in weeks until the next earthquake happens. So we can also say that x will be greater than t if and only if we are sure that no earthquake happens within next t units of time. So we can say this, and we have to calculate probability distribution function of time, that it is here it is random variable capital X. So we can say we have to calculate probability when the random variable x takes value is smaller than or equal to t. Alternatively, we can say we have to calculate 1 minus and the probability of random variable x taking values greater than t. So here we calculate probability of random variable x taking value greater than t. As we said here, x will be greater than t only if and only if no event occurs in the next t minute. So we can say its probability will be number of earthquakes in the next t equal to 0, that is k equal to 0. We will put the value of k equal to 0 in this equation and we will get the probability of no earthquake happening in the next t unit of time. So 1 minus e to minus lambda t, e to the power minus lambda t will be the probability of x being greater than t, and 1 minus e to the power minus lambda t will be probability distribution function. So we put the value of lambda equal to 2 and we will get the required distribution function of time.